Let's now talk about the out of bag error. So what is the out of bag error? So remember that we have drawn our bootstrap samples from only 2/3 of the data. The remaining third we did not use for training, and therefore we call it out of bag. And this is similar to cross-validation, but it won't be like cross-validation, and we will see why. But I will first note this down, and then I'll show you an example that might illustrate better what I mean. So it's similar to cross-validation. So I think it's not officially called in-bag, but just to make it clear, so this would basically the data set or this subset that goes in a bag where we pull our or we draw our bootstrap sample from. So the remaining 1/3 was not used for training. So it was unseen by our model, and therefore it is out of bag. So having these many bootstrap samples and many out of bag samples, we can calculate out of bag predictions. Which will be the average over the predictions for all the single out of bag sets. But I will show you an example that might illustrate this better than this formula can do. Because I don't find this too intuitive, this notation. So let's go with an example. So in our example, we have the data set that only contains of 3 observations with multiple features. Okay, so obviously this is far from realistic, but let's just assume that. And now we draw the first bootstrap sample. And we said we only use 2/3 of the data. So we randomly select now 2/3 of a data, which might be x1 and x3. So this is basically the bag we draw from. And now we will draw from this our bootstrap sample. And as we said before, our bootstrap sample contains of n observations. So we will draw with replacement, and this could be then, for example, x1, x1, and x3. So with this bootstrap sample, we will then train f hat 1. Okay, the first model. And then with the leftovers of the set, we will basically draw the out of bag set. So x2 was not included in this bag, so it is out of bag. And this will be our out of bag set. So then we can continue this procedure and draw the second one. And then the bag contains again only of 2/3 randomly selected from this data set. And this might now be x2 and x3. Again, from this bag, we select our bootstrap sample. Now calling this now the bag might not be the appropriate scientific term, but I think you better understand than the procedure. And then drawing from this bag, from this subsample, we draw our 3 observations that we use in the bootstrap sample, and using then the leftover x1 as our out of bag set. And this will now continue b times, because we selected B, or we are selecting B bootstrap samples, and then for every bootstrap sample we can calculate our prediction model. So this would be F2 and so on until FB. And then using the models, we can average over the models to calculate our bootstrapped or our bagging model, the bagged model, as I showed before. But now we can also calculate these out of bag errors, or out of bag predictions rather, not the errors. And then we can use them to calculate this overall out of bag prediction. Okay, and then having this out of bag prediction, we can calculate the out of bag error using these actuals and the out of bag predictions. So we can note down so we can then use these predictions that we have and the actual values in the out of bag set to calculate the error and the metrics that we are interested in, for example, the out of bag MSE. And that's also the difference between, let's say, cross validation and out of bag error, because you think, it's also something about drawing samples and then averaging over it. But you have this procedure of subselection that is a little different.